Hello everyone. Today we're going to be doing an arthropod dissection. Specifically, we are going to be dissecting some crustaceans. The crustaceans we are going to be dissecting are crabs. We have a speckled crab and a blue crab. Now both of these crabs are termed swimming crabs. We'll talk about why in just a second. So they're very closely related. They share a very similar anatomy. I remember one of the first things that all arthropods have in common is that they have three different main body segments, right? Their bodies exhibit segmentation, but they have three main segments: a head, a thorax, which is sort of like your chest area, and an abdomen. For our crabs here, they have fused their head and thorax into one segment called the cephalothorax. Many other arthropods have done a similar thing. Their abdomens are actually tucked underneath their bodies. Now we can sort of see abdomen, cephalothorax, head and thorax. One cool thing about the abdomen of the crab is that by looking at its shape, we can tell whether the crab is a boy or a girl. The abdomen that is shaped sort of like a rocket ship is the male abdomen, and the one that's sort of shaped like a half moon is the female abdomen. If we sort of pop them open, we can see the male reproductive organs, which are paired in the crab, and then the female reproductive organs. These little swimmerets are for holding her eggs, and then the openings to her female reproductive system are right there. In addition to looking at the bottom of the crab, the abdomen, that's sometimes called the apron, we can also look at a blue crab's claws to see if it is a female or a male. The females have red on the tips of their claws that are otherwise blue. A male would just have straight blue claws. Some people like to say that the female blue crabs paint their fingernails, and that's why the red is, the tips of their claws are red. Just some kind of funny way that you can remember that by. All right, the main body of the crab is protected by a hard exoskeleton called a carapace. This main shell on top of the crab is called the carapace. This is one of the first things that is molted as the crab grows. It sort of pops its carapace up and slides out the backside. But if we look at the crab's carapace, we can see that there are some barnacles, which remember are also crustaceans, closely related to crabs, growing on the back of the crab's carapace. This could be a symbiotic relationship, right? The crab gives the barnacles a place to live, and then the barnacles help the crab to blend in with its surroundings a little bit better. Remember that one of the other big things about arthropods is that they have appendages, things sticking off their bodies, that are jointed. Think about your elbows or your fingers or your knees. Those are also jointed appendages you have, and they allow the organism to have more complex movements. If we look at the crab, it has three different types of leg/arm-like appendages. The first two most striking ones up front are called the cheilipeds. The cheilipeds hold the chela, which is another name for the claws. In the middle, there are three pairs of walking legs. And then in the back, for a swimming crab, like these two, there is a pair of swimming legs. Notice they look sort of like little canoe paddles so that the crab can paddle along through the water and swim. Not all crabs have these. If you catch a crab and he has the swimming legs, you know that they're a good swimmer. If they don't have them and all of their legs just look like these little walking legs, then they're only a walking crab. Together, the walking and swimming legs are called periopods. All right, I'm going to go ahead and break open one of the cheilipeds, and we'll look inside and see if we can see some of the crab's muscles. The muscles are the tasty part that you like to eat. So I have some crab claw crunchers that you usually use when you want to eat a crab. And we can look at this movement right here. Crab is able to move its claw open and shut to pinch things for self-defense and also for catching prey. Right? If we break this open, remember that one of the functions of the exoskeleton was to help with movement. We should see lots of muscles. Here's a muscle, a tasty muscle, and it attaches, it's gooey, it would attach to different structures of the exoskeleton, like this hard bony part right here. And by pulling on that parts of the exoskeleton, it accomplishes the movements. All right, if we look at the front of the crab's head, or cephalothorax, where its sort of face would be, we can see a couple different structures. First, we see some antennae. There are two different pairs of antennae. There's one pair and another one in the middle. Antennae, remember, are organs that some arthropods have that help them to feel around. They're sensory organs. We can also see the crab's eyes. They're on stalks. They're on stalks so that the crab can bury himself under the sand and then just poke the little eyes out so that he's safe but can still see his surroundings. And finally, the crab's mouth parts function sort of like arms. They're called maxillipeds, and there's a couple different layers of them. There's one layer, there's another layer inside, and at the very center of all the maxillipeds is the mouth. So when the crab catches food with his claws or rips something off, he passes it into the maxillipeds that sort of grab it and manipulate it and help to shove it from one set of maxillipeds to the next set of maxillipeds into the mouth. All right, so now it's time to look at the internal anatomy of the crab. So what I'm going to do is I'm going to take some scissors and I'm going to try to cut as best I can away at the crab's carapace to reveal its internal organs. We could rip the entire carapace off, but that might damage some of the organs that we want to take a look at. Okay, so I've removed the crab's carapace. Now what you're seeing here is a soft, gooey membrane. This is a membrane covering all of the internal organs. This is what would harden into the crab's new exoskeleton once it molted its old exoskeleton. So I'm going to go ahead and remove all of this membrane so we can get a better look at the organs underneath. Alright, so I've removed the membrane. Now what you see right here, the first two things on the side, they're sort of orangish. These are called the hepatopancreas. The hepatopancreas is a digestive organ that we do not have that's similar to our pancreas and our liver and some of our other organs that secrete digestive enzymes. Remember that enzymes help to speed reactions up? These help to speed up the reactions that digest the crab's food. All right, I'm going to go ahead and remove those, the hepatopancreas. All right, now we see right where the hepatopancreas was attached. This sort of bag-like structure, you can see it sort of inflating when I press on it, is the crab's stomach, where the hepatopancreas attached and released digestive enzymes into. Right behind the mouth. Right below the stomach is the crab's heart. And then on the sides here, these feathery structures are the gills. I'm going to go ahead and pull some of the gills out. If you've ever eaten a blue crab before, right, the gills are really, really nasty tasting. Some people eat them on accident, and they call them dead man's fingers because that's what they kind of look like and taste like once they're cooked. So here's some of the gills. They're also sort of layered so that there's lots of surface area. All right, if we pull the stomach away, we reveal these sort of white stringy organs. These are the male gonads producing the male gamete, the sperm. After the food passes from the mouth through the stomach and is digested with the help of the hepatopancreas, it travels through the intestines, Right here we can see the intestine, this long tube, out to the anus. So they do have a one-way digestive tract, indicating some complexity. If we squeeze on the anus, we can see some crab poop. Okay, now let's take a look inside our female crab and see the differences. I've removed the carapace from the female blue crab and most of the internal organs, the heart and the stomach. Underneath those organs, we see a very bright orange material. These are the female gonads containing the eggs. Hope you enjoyed the video and learned something new. Bye!